Thanks for choosing to listen to this Late Night Linux Family podcast. We're only able to do this because of the people who support us. None of our shows are paywalled, but our Patreon supporters can get most episodes early and never hear any ads. Learn more at latenightlinux.com/support or support us by telling a friend or colleague about everything we do. Hello and welcome to episode 152 of Linux Dev Time. I'm Joe.
I'm Omeleth.
I'm Kevin.
And I'm Andy.
Good to talk to you all again. Last time we talked about what makes a good library, and following on from that, it made you think about specification and implementation, Omeleth.
Mm-hmm. So I've not done a ton of spec writing. I don't think I've done any spec writing. I have done a very little bit of implementation from specifications. But what brought the topic to mind was seeing some discussion in the XMPP community around people's preferences for whether they should implement something and then write a spec based on that implementation, or come up with a spec and then implement to the spec, or do both at the same time somehow. And it seems there are a lot of different approaches for this process with trade-offs. And I guess I'm curious, especially what Andy thinks, given all the work he's done on Matrix, and Kevin, if you have any thoughts.
So I guess we should start off by talking about what kind of spec we're talking about.
Not spec-driven development.
Not spec-driven development, but also whenever you're doing any software project, you need to have some kind of idea what you're doing. And people often talk about that as a spec. And maybe that is part of the conversation we're having here. But my understanding of your question, Amalith, is you're talking about something that is going to become part of like a formal specification that's published that other people are going to implement to not just your own code. Is that right?
Yes, more like a protocol specification rather than an implementation specification.
So more standards rather than this is what we're going to do for our particular project.
Right.
So yeah, in the Matrix world, there's a way of approaching this that has become established as the norm. And I think it's partly based on like bad experiences with other spec processes in the past. There's sort of some people involved with Matrix had been involved with things like the IETF and things like that previously. Not to say that those processes are bad, but they can sometimes be quite painful and slow and even sometimes diverge from what's actually getting implemented. So in the Matrix world, you can write a piece of spec whenever you like, a proposal for a change to the spec. But if it's going to get merged as a formal part of the spec, there needs to be an implementation demonstrating that it makes sense before you can do it. And I've actually seen a similar movement in the C++ community where some features were introduced without anyone actually implementing them in compilers. And then at some point they realized they couldn't implement it in the compiler and it never got done. So yeah, I think there's a movement towards, we need to be a bit more careful to make sure things are realistic and fully thought through, which you can only really do by implementing the thing at some point in the process.
Yeah, Amalith, you originally asked something along the lines of, do you write the spec first and then implement, or do you implement first and write the spec to that? And at least in the little bits that I've worked, and it hasn't been like formal specifications or anything, it's been a little bit of both. If for exactly the reasons that Andy just stated, you might have an idea of some specs, so you might write a little bit of it, and then you have to implement some of that to make sure it's realistic. And you might come up with eventually what is a like good base spec and a good base like prototype implementation that you can then go and like massage either or. At least the projects that I've worked on before, they have then tried to polish off the spec first and then redo the implementation based off the spec. And that sort of like cyclical approach to it has been the best results that I've seen. If you try to do just the spec by itself, you will inevitably run into areas where when you try to implement it, it's just unrealistic. It doesn't work that way. And the reverse of that, if you just build the implementation, you try and build a spec from that, it's usually not precise enough, or there are a bunch of edge cases that you have to then rethink about. So this sort of like in tandem kind of is a good middle ground that I've found before.
Are you talking about kind of an iterative approach then, where you write the spec, write some of the code, realize, we need to change the spec a bit, and kind of go back and forth with it?
Yes. And then once you eventually arrive at what you can say, like, okay, cool, I think the spec is basically complete. From that point on, you can either try to re-implement to the spec. You could either just polish up the prototype to the spec, but then changes to the spec have to go through a more formalized process to try and add or change something. And then that will drive kind of updates to the other thing. But even both of those, you kind of do them in tandem because they can't really exist one without the other.
Yeah, and I think generally an iterative process is really important, like going rounds of feedback, not just between the spec and the code, but also just on the spec. I've often thought, oh, this is straightforward. I'm going to write up a spec change proposal, which is what we call them in Matrix. And for a very simple thing, you generally think, basically, because the implementation's kind of already in my head, well, then I can just, I've already done that bit of the cycle, right? So I can just write up my change. But then in the Matrix world, that then goes in front of people to get reviewed, or it's just put out in the world for people to make comments. And inevitably, there's stuff that I didn't think of, or there's wording that's confusing, or all kinds of stuff like that. So just getting the feedback in that process is really important. And then if you're the person who's either implemented it or going to implement it, you might well push back against that feedback because of what you've learned from the implementation. So I really think that stuff goes hand in hand, and it's really important that there's cycles of feedback.
Yeah, that round of feedback, I think, is ultra important. Feedback like on the spec itself as you go through changes, or even sometimes just when you're building the base spec, because exactly like you said, there will be feedback that you didn't think about. But when you're talking about the spec specifically, you often don't have to consider some of the real world implications of the language specific details that can often get in the way of the spec itself. And it's difficult to talk about these things in abstract, but when you are designing something like a protocol, it's often more helpful to talk about those things in sort of an abstract, not having to care about the actual language semantics. And then you can kind of go back and forth. And then when you want to implement that in said language or a particular language, that might have to drive parts of the spec, but it's better to talk about the spec sort of in isolation.
So, Amleth, have you found that parts of the XMPP spec are a bit underspecified, and it turns out that people are just implementing what everyone else does without that being in the spec? That's something we definitely see in the Matrix world.
I've not noticed that, but I think it's more because I'm not watching what everyone else is doing and comparing with the specs necessarily. I have seen that other clients will copy features before there's a spec.
Right, yeah.
And multiple clients having a feature before there is a spec, I think makes it so that all of those people can collaborate on a spec that reflects the diversity of their implementations.
Which is both good and bad, right? Like, so if there's like exactly. a shadow spec that is what people are really implementing, that can be a real problem. Mm-hmm. But on the other hand, I mean, especially given that the Matrix process mandates that you have to have an implementation, you are basically forcing people to implement something that isn't yet spec'd or isn't formally accepted into the spec. So there's always a balance there. There have been some times, especially because the Matrix spec started out quite informal and has become more formal over time, which is probably the right way to do it. But when Kevin was talking, it made me think about the thing that's happened in the Matrix world, which is that there's this concept known as canonical JSON, where you've got some information being transferred in JSON, but then there's a cryptographic signature over that information. So it has to be byte for byte identical, not just JSON identical, if you see what I mean. And it turns out that hadn't been spec'd carefully enough, and it was essentially just what Python did. And there's a few places where what Python does became the de facto spec, and then retrospectively has then had to be written into the spec like that, or there have been changes, which is somewhat unfortunate.
Yeah, I think that's all too often the case when they'll say, like, this is just the reference implementation. So whatever it does is what we meant to do. And that is really, really hard when you're looking at the details of something and trying to re-implement it either in another language or even just re-implement it in the same language, because it's often hard to tell, like, did the author do this because of a reason, or is this just like the byproduct of how the language happens to work? And that can be a frustrating experience.
Absolutely. So one of the ways that we manage that process of there are implementations out there, but it's not in the spec yet, is that we have this concept of an unstable identifier. So you're not allowed to use one of the official looking identifiers for the names of your things until the thing's merged into the spec. And up until then, you use a name. So if you're writing a bit of JSON, your JSON property might be like my domain dot my feature, whatever. And then everyone knows that could change later, but they can still try it out and work with your code in the meantime. And that generally, it's better than not having that, but it can get awkward. Like what happens when you have my domain.myfeature.version 3 or whatever, and then it all gets very confusing.
Especially if like that becomes the de facto thing that everybody uses and that's not officially in the spec yet. There's this like tricky situation too, where once you have a spec, usually the purpose of a spec, and I guess we could talk about like there's multiple reasons for a spec, but like one of the big purposes is so that you can have multiple implementations of something and they can all be interoperable or coordinate together. But that can also mean that like advancing the spec is somewhat necessarily hard because there are multiple, sometimes unknown numbers of implementations of this thing, and advancing that spec in a way that's either like backwards or forwards compatible can be extremely tricky.
Yeah, and like whenever you talk about versioning, I feel like the lesson that you should take away is version early, version often, right? And if you're using even one of these unstable identifiers, if there's going to be any doubt about it, if someone is using your unstable identifier and then you change what it means or how it works, give it another version, and just always give it another version, and then there'll be less confusion. Although, of course, it will mean that stuff won't work with your new thing, so you have to be prepared to pay that cost. The idea with the unstable identifiers is that everyone who implements something using that unstable identifier is aware that they're going to have to make changes later and are prepared for it. And in Matrix World, that mostly works, I would say. We have more of a problem with stuff being implemented where there's no specification been written, and everyone's interoperating using it anyway because that's just what the default does. We've been trying to get rid of some technical debt. We actually done pretty well about getting rid of most of that technical debt, but it's definitely been hard. Specifying something years after it was implemented is hard.
So what do you do if your specification is open source and an open standard, and you have multiple stakeholders, for want of a better word, arguing about what should be in that spec? Like, does someone just have to take charge ultimately and say, if you don't like it, fork it?
I guess it depends on how that standards body decides to govern themselves. In some cases, maybe there is a benevolent dictator for life who has final say on things like that. In other cases, maybe it's some sort of voting process.
I feel like the Matrix spec process was invented after like trauma from lots of other processes. So one of the things about Matrix Land is that there is a group of people called the spec core team, and they have a final say. A certain number of the members of the spec core team have to approve a change for it to get merged, and there is only one official specification that contains the stuff that's been merged.
This is one reason we say that like the sort of soft skills of software engineering are so important, like articulating your ideas. I would say like politely and professionally arguing for your ideas to get in, because like not everyone always agrees. In fact, it's very rare that everyone always agrees. And when it's for something like a spec, like that can have big changes in the future, whether or not your idea is accepted or not.
Yeah, and I think we talked before about like contributions to an open source project and like which ones to reject and which ones to accept. And we said at the time, a very important part of that is having a clear vision for the project that you've articulated. So then you can say the reason why this contribution isn't going to go in is because it doesn't fit with the vision. And I think with a spec, you very much need that as well. You've got to have a vision so that you know what's appropriate to go in the spec or not, and whether there's such a thing as stuff that lives alongside the spec but doesn't go into it but kind of cooperates well with it. But I think the difference with a spec process often is that there's a lot of momentum behind the people involved. So there might be companies spending huge amounts of money on implementing something that they hope is going to end up in the spec. So it can be particularly painful if something gets rejected.
Presumably documentation is really important here, like to lay out exactly what is expected.
Absolutely. And in particular, that vision that says, like, that means that you can give a good reason if something is not going to be accepted, or better still, that people don't start out down a road that isn't going to work.
Yeah, and the spec can also exist for different reasons, right? There can be a spec that is there for security reasons, right? Like and those might dictate a little bit more of like the how something happens, like this process does this in this way because we're trying to protect security in these other manners. You could also have a spec for like interoperability and saying something like the inputs to this result in the outputs of this, or this is how it operates, but like how you do that inside of it, like who cares? So long as it is, the same inputs and outputs. So knowing like why the spec is being written can help with those, like, is this appropriate to add to the spec or not?
I haven't been involved directly, but my understanding in certain worlds, maybe in the web world and things like that, is that when you're not certain of the motives of the actors involved, things get really difficult, right? Like, I don't know, maybe we should talk about like HD DVD versus Blu-ray or something. There's people who are investing a huge amount of money in making their way be the way, because then they make a ton more money.
Yeah, I don't know that I have a particularly salient example of this, but in a like open source type spec where you have a huge company come in and say like, we want to add this to the spec because our implementation already does this, and we would like it to be like the thing that everybody can then be interoperable with us, and we're the dominant user base of this. That can be particularly tricky because there's pressure from the governance body to either like just accept that as the way it is. Yes, that's the biggest part of the user base, and or to be like, no, we don't want one particular company or entity to control that large of thing. It can be a huge, I would say like almost political battle just for like untechnical reasons. I imagine that's a very difficult thing to deal with. Thankfully, I have not had to deal with anything like that in my career.
Yeah, I certainly think if you think about email with, when Microsoft and IBM came in and tried to make it be whatever they decided email should look like, and then later Google came along and said, technically email's still distributed, but actually the only emails that actually arrive come from Google servers. That's the kind of thing that can be worrying for someone who's looking after a potentially or supposedly open spec. If someone comes along essentially looking to make it less open deliberately.
I'm curious if either of you have ever dealt with like informal specs. And this is probably just like something that I've seen in my own career, but a lot of software engineers are, I would say, like somewhat more prone to want to write informal specs because that like helps clear up the problem in their head. So they'll write almost like little parsers or grammars for a particular thing they're working on, which is, it doesn't turn into a formal spec. It's not interoperable anywhere, right? It's just something to like help them explain the problem for the thing that they're working on. I've seen that like with some frequency, so I'm curious if either of you two have as well.
I don't think I've explicitly noticed it.
It's possible also too, just like the domain that I've worked in a lot, where like low-level network stuff, that's more common there. But yeah, it just seems like something that I've seen at multiple companies, multiple groups of people, right? So it's not just a single group, where there seems to be a bias towards wanting to write down a grammar-ish style thing for whatever it is they're working on.
That sounds really good. I often wish that people stopped and documented what was going on. Normally what I found is things being underdocumented. I mean, I think if you're writing like an actual protocol, then I think it feels quite natural to make it more formal. Often where I see gaps is when you're just writing some code and no one's particularly thinking about the overall structure, and I would like to see more there.
Yeah, I've worked at a few different places that enforced sort of a RFC, or request for comments, request for discussion, RFD, like whatever you want to call the document. I've seen a few places that sort of require those sorts of upfront thinking about larger pieces of programs or systems. And they sort of result in this like mini spec type thing where you build up the RFC or the initial implementation, possibly with a prototype, and then that gets commented on and either accepted, modified, or denied, and you kind of start that process over again. But it's not until like something is formally sort of accepted that it can go into production and then be utilized, and then changes to that would either require future RFCs or perhaps an RFC update, depending on how your organization does it. But like that has been a surprisingly beneficial thing. However, it's hard to keep up at like a large company, right? Like you get beyond a certain number of people and it like everyone's writing RFCs and they're not writing as much code.
Was that always a helpful thing? Did it actually slow progress? Did it prevent having rounds of feedback between the code and the spec?
I would say it is mixed, like generally more positive. However, the organization and the company or whatever have to be behind it and fully support it as well, because it does slow down progress, right? Like when you're writing a not perfectly like academic formal, but when you're trying to write down a formalized document on how something's going to work and the invariants that it holds, that takes time. When you're going to do a prototype, that takes time. When people are going to comment on it and you're going to make changes on it, that takes time. So the organization has to be fully supportive and behind that, not just driving the like new features tomorrow sort of thing. And if the organization is supportive of it, I've seen nothing but like massively positive things come out of it. That's not to say there aren't things that get slowed down unnecessarily or things that couldn't be done a little bit quicker, or that there's not like arguments that happen over, silly details of it. Like that, we're human, right? All of that sort of stuff happens, but it is more positive than negative. Now, if the organization is not supportive of it, then it usually just kind of dies by the wayside because it does slow things down.
That is very interesting, because I've definitely worked in situations where like the formal roadblocks were slowing things down. The current situation I'm in, it's an interesting question about organizational support. So like my organization Element consists of all the people who wrote the Matrix spec, right? And is extremely supportive of that spec existing and being right. But it also makes products and employs people who are product managers who don't care about the spec. They only care about, like, we've got a feature that we want to deliver so that people get to use it. And so there's like this culture clash there, and we have to like make space to do that spec work. And it always pays off, because otherwise we end up doing it later and it's even harder and worse, and everyone hates us for it. But yeah, it's definitely a tension there.
Yeah, and you really have to have some form of leadership. What doesn't really matter kind of which level it's at, but that owns or kind of drives that process, because there can be tendencies for people to want to write like RFCs or specs about something that like absolutely doesn't matter, right? Like you don't need to spend time writing an RFC on re-implementing a like network RFC thing. Like we're gonna have to implement it the way the RFC states. So there's some of that sort of stuff that'll happen. There's also like people that are just sort of naturally averse to writing. So they'll say like the most minimal amount possible and say like, this is me documenting it. So like, it's not an easy process, but I do think when you have some level of ownership and support from the organization, it can be very beneficial, because you also have this record of decisions, you have records of discussions that happened, and even like onboarding new people, pointing them at the RFC repository and say, go look at the things, like this is how we arrived at where we are today, is massively beneficial. And especially when you're talking like whole subsystems, you're like, oh, this is why we're at where we are, and this is what the decisions were made. And it also gives people a little bit more of empowerment to make changes to that, because it's just a matter of like either creating a new RFC or updating an old one. And you can also see if like other ideas have been tried before or not. And if they haven't been, great, open up an RFC and, discuss it with the people. So I found it to be very beneficial, both for like new people coming onto a team as well as well-established teams. But not every place does it. And if you don't do it at your organization, that's not bad. I've worked in plenty of places that don't do this at all either.
That's got me thinking about my situation again, because we have the Matrix spec, which is like extremely formal, and you have to go through a lot of review process to get stuff reviewed or get stuff approved. But what's interesting, something I've noticed, is that for areas of our code that don't involve the Matrix spec, maybe they're just implementing some completely client-side feature, doesn't involve anything over the network, we have a tendency not to specify that very clearly, because there isn't really anywhere to put it, because the place where we put our specs is the formal spec. So yeah, sometimes that can leave us with a bit of a gap.
Yeah, that sounds like a spot where you could absolutely just have like this internal sort of decision record or discussion record for the team. And that can be very helpful.
Yeah, I've used architecture decision records a few times, which are like sort of one-page things where you describe like, we made this decision and why. I found that pretty helpful.
Right. And this can span that, or it can be inclusive of it. There's also like, it may not be an architectural decision. It could just be like a request for a discussion on a topic. And that's been very beneficial. So like the naming of the thing, whether it's a request for comments, request for discussion, architecture review document, or like there's all kinds of different acronyms that you could use, but saying like this can encompass anything. And it could just be like, here is the discussion I want to have. Here are the points that we make. Like that can be very beneficial. Like the Rust RFC process is a really good one. It is now like very complex, and I would say somewhat convoluted, because Rust is a very complex and large project and it's very public. There are companies out there that have a very public RFD process where they even go over like, this is how our RFD process works. So they make a lot of their RFDs public as well, so that you can review them. So like there's a lot of good examples out there for like how to do this type of process if one is interested in it.
Well, it looks like the formal process of this podcast has finished, so we'd better get out of here. We'll be back in a couple of weeks, but until then, I've been Joe.
I've been Amalith.
I've been Kevin.
And I've been Andy.
See you later.